Hi students, in this video I am going to explain you about inverse of matrices. In the previous videos we have seen about cofactors of matrix, okay? And next we have seen about adjoint of matrix or adjugate of matrix. Now in today's video we will learn about how to find inverse of a matrix, okay? Inverse of matrices. Let us do for both 2 by 2 matrix and 3 by 3 matrix. Okay, students? Okay, so how to find inverse of a matrix and how it is denoted. Suppose I have a matrix A. I have a matrix A. A inverse is denoted as A power minus 1. Okay, so and it is read as A inverse. Okay, A inverse. Okay. So this is the reading part and this is the writing part. Okay, students? Okay. So the formula for A inverse is given by, okay, 1 by absolute of A into adjoint of A. This is our formula. So 1 by determinant A. We know how to find the determinant of A, right? Already we have covered in our determinants video. Okay, students. So A inverse is given by 1 by determinant of A into adjoint of A, where this determinant of A should not be equal to 0. If determinant of A is equal to 0, then inverse of matrix A is not possible. Understood? There is no inverse for matrix A if its value of its determinant is 0. Okay, we can find A inverse only if determinant of A is not equal to 0. Now let us take some examples. I have a matrix A. I am going to take a 2 by 2 matrix, students. Okay, 2 by 2 matrix. Let us see 1, 3, 5 and minus 2. So what is the formula? We have to find, first we have to check the condition. How to check the condition? Determinant of A is given by, so 1, 3, you know how to find the value of its determinant. So just 1 into minus 2, okay, minus of 5 into 3. This gives minus 2 minus 15, that is equal to minus 17. And is minus 17 equal to 0? No, it is not equal to 0. So this clearly shows that the inverse exists for this matrix, 2 by 2 matrix. Okay. So how to find? We have to find adjoint of A. Adjoint of A is found how students? First we have to find the cofactor matrix. Okay. We have seen in our previous videos. So cofactor matrix. Then inverse of, then cofactor matrix. Afterwards find adjoint matrix. Okay. Transposing a cofactor matrix gives our adjoint matrix. Okay. So let us do this now. Okay. Let us find cofactor of A. Okay. So how to find the cofactor matrix? So first one is A, 1. Avoid its rows and columns. Then the remaining element will be minus 2 and the place value is positive. Okay. So let us consider the signs positive, negative. This is negative and this is positive. Okay. So now what's happening here? The first element is 1, avoid its rows and columns. 2, its place value is plus, plus of minus 2 is minus 2. And next 3. So avoid rows and columns for 3, you will get 5. and its place value is minus, so negative 5. Next, 5, avoiding rows and columns of 5, we will get 3 and its place value is negative. Okay, and next, minus 2, avoid its rows and columns, we will have 1. Okay, and it is positive. This is the cofactor of A. Okay, now find the adjoint of A. Adjoint of matrix A is given by just interchange its rows and columns. Okay, just interchange its rows and columns. Minus 2, minus 3, minus 5 and 1. Did you understand, students? Now let us find the inverse of A. Inverse of A, that is A inverse. So what is the formula? 1 by determinant of A into adjoint of A, that is equal to, so what is the value we got? Minus 17. So minus 1 by 17, and what is adjoint of A? Minus 2, minus 3, minus 5 and 1. Okay, did you understand, students? This is how we are going to find the inverse of a matrix. Understood? First find the cofactor matrix, then find the adjoint matrix by changing rows and columns of a cofactor matrix, and then find inverse of a matrix by the given formula 1 by determinant of the matrix into adjoint of the matrix. And the determinant of a matrix taken, whether it is 2 by 2 or 3 by 3, should not be equal to 0. If it is equal to 0, inverse is not possible. We cannot find the inverse for that matrix. So did you understand, students? Let us now take another example of 3 by 3 matrix. Okay. So now let us find out inverse for a 3 by 3 matrix. Okay, students. So I am going to take a 3 by 3 matrix. And the matrix is 1, 1, minus 1. So whatever numbers you want, you can take, students. 2, 1, 0, minus 1, 2, 3. Let us find inverse of B. We have to find inverse of B. Okay. So for this, what we have to do? We have to find the value of determinant B. Okay. So how to find? First one is 1. Let us check its signs. Okay. This is positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay. So now, very easy, students. So find the value of determinant B, 1, and avoid its rows and columns. The remaining determinant will be 1, 0, 2, 3. Okay. Next is 1. Its element sign is negative, so minus 1. The remaining determinant will be 2, 0, minus 1, 3. And next is minus 1 and its place value is 1. Plus of minus is 1. Okay. Avoiding rows and columns of minus 1, we will get the determinant 2, 1, minus 1 and 2. Now find the value, students. So 1 into 3, 3. Okay. Minus 2 into 0. And next minus 1 into 2 into 3, minus of minus 1 into 0, students. Okay. Next minus 1 into 2 into 2, minus of minus 1 into 1. Now solve this. So 1 into 3 minus 0. This is 3. So minus 1 into 6 minus 0. This is 6. And minus 1 into 4 minus 1. 4 minus of minus 1 gives 4 plus 1. And this is 5. So the answer is 3 minus 6 minus 5. So this gives the answer 3 minus 6 minus 3 minus 3 minus 5 gives minus 8. And this is not equal to 0, means B inverse exists. We can find the value of B inverse. Did you understand, students? So now to find B inverse, first we have to find a cofactor matrix, then adjoint matrix, and apply the formula. Okay. Now let us find the cofactor matrix, students, for B. Okay. So here it is our 3 by 3 matrix. So how to find a cofactor matrix, students? So let us find the cofactor matrix now, okay? So cofactors of 1. The first element I have taken 1, okay? If you avoid rows and columns of 1, the remaining determinant will be 1, 0, 2, 3. Understood? Now find its value. 1 into 3 minus 2 into 0, that is equal to 3 minus 0, that is equal to 3. Understood, students? Next, cofactor of next element, students. Okay, so this is positive and next element is 1. Its sign is negative. So the remaining determinant is 2, 0, minus 1, 3. That is equal to minus of 2 into 3 minus of minus 1 into 0. Solve this, students. You will get minus of 6 minus 0, that is equal to minus 6. Okay. Next element is, students, cofactor of minus 1. Okay, its place value is positive. What is the remaining determinant? Avoiding rows and columns, you will get 2, 1, minus 1, 2. That is equal to, it is positive. So 2 into 2 minus of minus 1 into 1. Now solve this, students. 4 minus of minus 1, that is equal to 4 plus 1 and its value is 5. Okay, the next element is cofactor of 2. So avoiding its rows and columns and its element sign is negative. Okay. So what will be the remaining matrix? 1 minus 1, 2, 3. Okay, 1 minus 1, 2, 3. Now find its value, students. Fatafat. 3 into 1 minus of 2 into minus 1. Okay, this gives minus of 3 minus minus 2. Minus of minus 2 is plus 2, that is equal to minus 5. Okay, next, what is the next element, students? Cofactor of. Next, what is the next element? 1. It's positive, sign is positive. What is the remaining determinant? 1 minus 1 minus 1, 3. 1 minus 1 minus 1, 3. Okay, find its value. 1 into 3 minus of minus 1 into minus 1. Okay, this gives 3 minus of minus 1 into minus 1 gives plus 1. 3 minus 1, that is equal to 2. Okay, so cofactor of, what is the next element, students? Okay, very easy now. Minus 1. So it is positive. So minus 1, sorry, 0. Next element is 0, students. Okay, 0, that its sign is negative. What is the remaining matrix? Avoiding rows and columns of 0. 1, 1, minus 1, 2. Okay, 1, 1, minus 1, 2. Find its value, students. Fatafat. Minus 1 into 2 minus of minus 1 into 1. This gives minus of 2. 1 into minus 1 is minus 1. Minus of minus 1 is plus 1. That is equal to minus 3. So what is the next element, students? Cofactor of, again, 1 and its sign is positive and its determinant. Okay. So minus 1. Next element is not 1, minus 1. Okay, students, positive 1 minus 1, 1, 0 is its determinant. 1 minus 1, 1, 0 it is determinant. Okay, find its value. 1 into 0 minus of minus 1 into 1, students. Okay, this is 0 minus of minus 1 is plus 1, that is 1. Okay, next, what is the next element, students? Cofactor of the next element is 2. Okay, 2 and its value is negative. Okay, and its negative and its element negative 2, and avoiding rows and columns 1 minus 1 2 0. Okay, 1 minus 1 and 2 0. Okay, students, negative of, find its value, 1 into 0 minus of minus 1 into 2. Okay, this is negative of 0 plus 2. This gives minus 2. Did you understand, students? Now, so next element, students, last element, cofactor of 3. So it's a positive. So 1, 1, the remaining determinant is 1, 1, 2, 1. Now calculate its value, students. 1 into 1 minus of 1 into 2. This gives 1 minus 2, that is equal to minus 1. Now what we have to write? We have to write the cofactor matrix of B. Okay, cofactor matrix B is equal to, so how I have taken, I have to place the answers for corresponding elements. So I have taken row wise, isn't it? So I have taken row wise. Let us place all the values. 3 minus 6, 5. Okay, 3 minus 6, 5. Be patient, students. Next, minus 5, 2, minus 3, minus 5, 2, minus 3, and the last row is 1, minus 2, minus 1. Up to here, clear, students? So now what we have to do? After finding cofactor matrix, we have to write adjoint matrix. So what is adjoint matrix of B? Just interchange the rows and columns. Okay, this is a 3 by 3 matrix. This is also a 3 by 3 matrix. So interchanging, we will get 3 minus 5, 1, minus 6, 2, minus 2, 5, minus 3, minus 1. Did you understand, students? Now what we have to do? We have to find inverse. Inverse of matrix B. So what is the formula? 1 by determinant of A into adjoint of A. So what is the determinant of A? We didn't get 0 now, so inverse is possible. So minus 8. So the answer is minus 1 by 8. Okay, students? Into adjoint of A. So that is 3 minus 5, 1 minus 6, 2 minus 2, 5 minus 3 minus 1. Did you understand, students? So in this video, we have found the inverse of a matrix of both 2 by 2 and 3 by 3 matrix. So what we have to do to finding the inverse of a matrix? We have to find determinant A, and after finding its value, the value should not be equal to 0, then only the inverse of a matrix exists. If it is 0, we cannot find the inverse of so and so matrix. Okay. So for 2 by 2 matrix, we have found, first find the cofactor of matrix. Find cofactor of matrix, then adjoint of matrix, and apply the formula inverse of A. A inverse is equal to 1 by determinant of A into adjoint of A. Okay. Next, here we have seen a 3 by 3 matrix. So we have find the value of determinant B, and it is minus 8. It is not equal to 0. So B inverse exists. So next, what we have done? We have found cofactors of all the elements inside the matrix and find out the cofactor of this so and so matrix. Okay, matrix B. Okay. Next, after finding cofactor matrix over, next find the adjoint matrix by transposing the elements of cofactor matrix B. Okay, students. Next the final step is finding out the inverse. Okay. Inverse of matrix B is given by 1 by det A into adjoint A. So apply the values. You will get the answer. Did you understand, students? If you really understand how to find the inverse of a matrix, do share to all your friends. Subscribe. Thank you.